All right, today we are going to talk about function notation applications. So being able to apply function notation, which is what we worked on last video, to apply to real life situations. All right, so a function notation makes it easier to recognize your independent and your dependent variables. Okay, so your independent variable is your x, it's your input, and it's your domain. Okay, it's what you input into the equation. Your dependent variable is your y variable, your output, and your range. Okay, so consider this situation. The Beta Club needs to calculate the cost of t-shirts for their national championship. They use the equation C equals 8s plus 5. The independent variable is S and represents the number of shirts ordered, and the dependent variable is C, the cost of the order. So your independent variable is the amount of shirts you get, and your dependent variable represents the cost. Okay, and that makes sense because depending on how many shirts you get will determine the cost of the order. Okay, so that's why the cost depends, the cost depends on the S, the amount of shirts we get. Okay, so because C equals 8S plus 15 is our equation, we can write that equation in function notation with the cost of shirts, C of S, equals 8S plus 15. And again, this can be read as the cost of shirts, S, is 8 times the number of shirts plus 15. When we calculate the cost of certain number of shirts using the equation, it's called evaluating the function. Okay, so we're going to evaluate this function. So your steps are right here. So let's calculate the cost of ordering only 4 shirts. Okay, so because we're ordering 4 shirts, 4 is going to be plugged into S. So you start by writing your function notation, which is the cost of shirts equals 8S plus 15. We'll rewrite the equation using S equals 4 and plug in 4 for S wherever there's an S. So this can be read as the cost of 4 shirts equals 8 times 4 plus 15. Then you calculate. Okay, so then you calculate 8 times 4 plus 15 and you get 47. So the cost of 4 equals 47, which is exactly what you would explain. So let's do an example. What is the cost of ordering 9 shirts? Use function notation to evaluate the function. So if our function notation is the cost of shirts equals 8 times the shirt plus 15. Well, if we want to order 9 shirts, I'm going to plug in 9 for S. So it's the cost of 9 shirts equals 8 times 9 shirts plus 15. When I plug in 8 times 9 plus 15, I get the cost of 9 shirts equals $87. And that's exactly what you would write down if you wanted to explain what this term of the problem means. So the cost of 9 shirts equals, is $87. All right, so now we're going to be able to identify the independent variable and your dependent variable. So your independent variable is what gets plugged into the equation or the function. So in this case, we plugged in S. So your independent variable is the number of shirts. Whereas your dependent variable is what you get out of the equation once you plug it in. Okay, so what you get out. So what your answer is. So in this case, it was the cost of shirts. Or money. Same thing with domain and range. So your domain, which is always your x value, which is again always your independent variable, will always be the number of shirts, because the number of shirts determines your cost. So your range is your cost because it is dependent on the number of shirts we buy. All right, we're going to do a couple more examples. All right. So evaluate the function C of S equals 8S plus 15 for each value and explain what each one means. So we have C of 7, so cost of 7 shirts. So the cost of 7 shirts will be 8 times 7 plus 15. So when we do 8 times 7 in our calculator plus 15, we get 71. So the cost of 7 shirts is $71. I want you to explain what each one of these means in terms of the problem. So at the end of every problem, you're going to put the cost of blank shirts equals this or is this. So I want you to do B and C on your own. So I want you to try B and C on your own. So pause this video, do that, and then so you can work those problems out and then come to the copy of notes and your answer should be there. All right, I want to go over D before we move on. So the cost of 2.5 shirts. So the cost of 2.5 shirts will be 8 times 2.5 plus 15. When we plug that into our calculator, 8 times 2.5 plus 15, we get 35. So the cost of 2.5 shirts is $35. Well, guys, yes, that is the answer, but you cannot order half of a shirt. So this question does not make sense. So like if your answer ends up being like half of a shirt or 3/4 of a shirt or half of a pant or half of a shoe, like you cannot have half of something in your answer. So in your answer choices, if you ever do see something like 2.5 shirts, that's not going to be your answer because you can't have half of a shirt, okay, or half of pants or half of a shoe, okay, half of a hat. So just be mindful of that when you're answering these questions. All right, so now we have, what if the Beta Club has $95 to spend and needs to calculate the number of shirts we need? So now we want to go backwards. We want to be given a value of how much it costs, and we want to find the number of T-shirts, okay? So we want to know how many shirts we can order. So if 95 is the cost, meaning the cost of shirts equals 95, we have to replace the cost of shirts with 95. So we take the cost of shirts and we replace it with 95. So that formula went from C of S equals 8S plus 15 to now 95 equals 8S plus 15. All right, and then we're trying to figure out how many shirts we need. So we need to solve for S. So we have 95 equals 8S plus 15. Draw railroad tracks. We're going to undo the subtraction or addition. So we're going to undo the addition by subtracting. We're left with 80 equals 8x. And then we divide off that coefficient. So x equals 10. So S is 10, not x. My bad, S. And the Beta can order 10 shirts. So that would be our explanation here. All right, so let's do examples. Find the number of T-shirts that Beta can order for each cost. Explain what each term means. Okay, so the cost of shirt is 55. So I'm replacing the cost of shirt with the number 55. So it's 55 equals 8S plus 15. And I'm solving. So I'm going to subtract 15. I'm left with 40 equals 8s. And then I divide off the 8. So s equals 5. So what this means, what this answer means is I can get 5 shirts for $55. All right. I want you to do B. Remember, it's the cost of shirts equals $175. So pause it, complete that problem, and check your answers in the copy of notes. And then we have C. Okay, I'm going to do C real quick because it's a little bit different, and I want to explain the answer and what that means. Okay, so we have C of S equals 150. So again, I'm replacing C of S with 150. So I have 150 equals AS plus 15. And I'm solving. So I subtract 150, or 15. I'm left with 135. 150 minus 15 is 135. And then divide by 8. When you put that in the calculator, you get that the cost of shirts, or the amount of shirts I can get, is like 16.875. Okay, the problem is you can't have 0.785 or 875 of a shirt. You can't have that. But I also cannot go over my budget of 150. So when it comes to money and when it comes to ordering things and when you're talking about a situation, you cannot go over your budget of 150. So the cost of shirts needs to equal 150. So you must round down because I can't get more than 16 shirts because I don't have the money for that 17th shirt. So the amount of shirts I can get is 16. So I can get 16 shirts for less than $150. It's not quite 150, but it's less than. I didn't go over budget. Okay, so I kind of wanted to go over that one and what that answer would look like. So you must round down when it comes to money. All right, functions as graphs. Okay, so function D of t, so distance of time, represents Gulliver's distance from home after t hours. Use a graph to evaluate the function at each value. Explain what each means in terms of the problem. So we have a graph over here. We have time that equals x because it's on the x-axis, and we have distance, which equals y, or it's d of t. And x, it means t, by the way. Okay, so I want to know a d of 2. So meaning this means that x equals 2. So time equals 2. So I'm going to look on my x-axis or my time axis and go to that 2. So here's 2. And what I am doing is finding out where is my graph when x equals 2 or when t equals 2. So I'm looking for my graph, and when I find my graph, I'm going to plot that point, and then I'm going to go find where it is on y. So it's on the 4 of y. So y equals 4. And when y equals 4, that's 4 miles. So our explanation is after 2 aisles, he's 4 miles away. So he's 4 miles away after 2 hours. So again, on the next one, I'm not going to give you the answer, but I'm going to kind of guide you. We want d of 5. So this means x equals 5 or t equals 5. So we're going on our x-axis, which is this one right here. And I'm looking for 5. Okay, I'm going to go up until I meet that point on the graph, so here. So you are then going to go find where it is on the y-axis, and that's how far he is from his house in 5 hours. So what about if it gives you the value of t that makes the equation? We want to give the value of t that makes the equation true. So this one says d of t equals 2. So d of t equals 2 means y equals 2. So we're going to our y-axis, and we're going to find 2. So here's 2. And I'm going to go until I hit the graph. So I hit the graph here at 1. But notice how I also hit the graph at about 9. A little bit more than 9. Okay? So when you're talking about the y-axis, on questions like these, you are going to have 2 problems because this one finds its way back down to the x-axis. Okay? So be mindful of that. Each of these are going to have 2 answers. Okay? So when d is 2, so d of t equals 2, so y equals 2, we have an x at 1 and at about 9. So how we explain this is he is 2 miles away at 1 hour and the 9th hour. So I'll do another one for you. B says d of t equals 5. So I'm looking at the y-axis equals 5. So I'm looking at my y-axis. I'm going to find 5. And I'm going to see where my graph is when y is at 5, when distance is at 5. So it hits here and it hits here. So it's about at 4 and about at 8.5. So x equals 4 and 8.5. So at 5 miles, he is 4 hours and 8.5 hours into the walk. So there's different ways you can say it, okay? All right, so I want you to try C. It's really easy, okay? You're just wondering when distance is at 0. So when he's home, when he starts at home and stays and gets to home, okay? All right, a table is a little bit easier, okay? Function of tables. So you use the table to evaluate the functions at each value. So explain what each one means in terms of the problem. So H is 7. So we have a boy's age and the average height of his inches, okay? So it's the height at that age. So here's our function. So that means age, the boy's age is also our x, and his height is also the y. So this is the height of the age. Okay, so because I have h of 7, I want to know how tall is he when he is at 7 years old. So x equals 7. So I'm going to look for 7, and he is 49 inches tall. So at the age of 7, he is 49 inches tall. Okay, so when it's h of 7, so height at 7 age, 7 years old, you're looking in your x column, okay? But say we are wanting to know h of a. So this means y equals 61. So I'm looking in my h of a column, which is the average height around that age, and I'm looking for the number 61. So if I look through all of these numbers, I see that 61 is right here. The answer to that is how old is he? So he's wanting to know how old will he be when he is 61 inches in height. So the answer is 13. So he is 13 years old at 61 inches. Average. Okay, so I want you to do B, which, by the way, 1.5 years is the same as 18 months. I want you to do C, and I want you to do B on number 2. Okay, bye, guys.